For this first function, f of x is equal to 8x, we're going to find the inverse and then verify that it's the inverse using this rule here at the very top. So this is a pretty easy one to find the inverse of if you're thinking of it logically. So you start with x and then you multiply by 8. So then the opposite would be start with x and divide by 8, right? Or take 1/8 times x. So that's the inverse. And again, you can always verify by using the rule where you start with your equation, replace f of x with y, and then switch your x and your y. So this becomes x is equal to 8y, and then you solve for y. So divide both sides by 8, and there we go. Our inverse is x divided by 8. Okay, so in order to verify that this is the inverse, the rule says that f inverse of f of x is equal to x. So we're going to show that f inverse of f of x is equal to x. So this is the composition of functions. So what this is saying is taking the inside parentheses, I'm going to replace f of x with 8x. So this is saying f inverse of, and again, all I'm doing is replacing the inside with 8x. So f inverse of 8x is saying for f inverse of x, this function right here, we're working with this function right now. Plug in 8x wherever there's an x. So right here. So this would be 8x over 8. And that's just x. So that checked out. Remember, you have to get x when you apply that. All right, finding the inverse of f of x. So we replace f of x with y. Then you switch the x and the y, so it becomes x equals 2/3 y plus 1, and then you solve for y. So the first step would be subtract 1 from both sides. So I would have x minus 1, those aren't like terms, so I just write it as x minus 1, and that's equal to 2/3 y. So in order to get rid of the 2/3, if you ever have a fraction, you would just multiply it by its reciprocal, because if you multiply it by its reciprocal, 3 over 2, that's equal to 1. So if I multiply this right side by 3 over 2, I have to multiply the entire left side by 3 over 2. So there's our inverse function. F inverse of x is equal to 3/2 times x minus 1. So there's our inverse function. And there's actually another way to write that. I'm going to write that up here. If I distribute the 3/2, 3/2 times x is 3/2 x, and 3/2 times -1 is -3/2. So that's a second way to write the inverse. So if this is true, then I'm going to use the rule f inverse of f of x is equal to x. So how do I show this? Let's replace the inside f of x with this function right here. So this would be f inverse of 2/3 x plus 1, right? So how do I figure out what f inverse of 2/3 x plus 1 is equal to? Well, that is saying for the function f inverse of x, I'm going to use the one where we distributed. So using that function, wherever there's an x, which is right here, we're going to plug in this entire expression, 2/3 x plus 1. So I would have 3/2 times 2/3 x plus 1, and then minus 3/2. So again, all I did was replace this x with 2/3 x plus 1. All right, so this expression, when I simplify it, should be equal to x. So let's distribute 3/2 to both terms. 3/2 times 2/3 reciprocals, that's just equal to 1. And then 3/2 times 1 is 3/2. And then if I subtract 3/2 from that, that's just equal to x. So that checked out.